In this video, we're going to look at how to integrate odd powers of sine and cosine functions. The examples we're going to work through are the integral of cos cubed x, sine x to the power 5, and cos cubed 2x. For all of these questions, we're going to follow the same set of steps, which I've broken up into 4 parts. First, split up the powers, then apply the trigonometric identity, use the u-substitution, and then integrate. For our first example, we're going to look at how to integrate cos cubed x dx. Our first step is to split up the powers. So cos cubed x dx can be written as cos squared x times cos x dx. And the way you want to split up the powers is such that you end up with one trig function to the power of 1. The next step now is to apply the trigonometric identity. We want to express cos squared x in terms of sine squared x. And we can use this identity here. Cos squared x is equal to 1 minus sine squared x. So that now our integral becomes 1 minus sine squared x times cos x dx. And what this allows us to do is the next step is to use the u substitution. We can say let u equal to sine x so that du on dx is equal to cos x or du is equal to cos x dx. So that means we can replace this sine squared x with u squared and cos x dx gets replaced by du so that our integral reduces to 1 minus u squared du. And all you need to do now is to integrate. So the integral of this is going to be u minus u cubed over 3 plus c. And the last step is to simply replace u with sine x so that our final answer becomes cos cubed x dx is equal to sine x minus a third sine cubed x plus c. Our second example is the integral of sine x to the 5 dx. We're going to follow the same set of steps. First, we need to split up the powers, so we can write sine x to the 5 as sine x to the 4 times sine x dx. And observe how I split up the powers. We want to have one trig function to the power of 1. Our next step now is to express sine x to the 4 in terms of cos x. There's a little trick here. First, we're going to need to write sine x to the 4 as sine squared x all squared. And what this allows us to do is to use the trig identity. Sine squared x is equal to 1 minus cos squared x, so that our integral becomes 1 minus cos squared x all squared times sine x dx. Then we're going to use a u substitution. This time we're going to say let u equal to cos x so that du on dx is equal to minus sine x or minus du is equal to sine x dx. So that means we can replace cos squared x here with u squared and sine x dx here with minus du. Our integral now becomes minus the integral of 1 minus u squared all squared du, and expanding this and applying the negative sign, we're going to get the integral of minus 1 plus 2u squared minus u to the 4 du. So then we just need to integrate to get minus u plus 2/3 u cubed minus u to the 5 divided by 5 plus c. Then we're just going to replace u with cos x so that our answer is the integral of sine x to the 5 dx is equal to minus cos x plus 2/3 cos cubed x minus 1/5 cos x to the 5 plus c. Our last example is the integral of cos cubed 2x dx. This time we have a compound angle 2x, but the steps remain the same. First, we need to split up the powers. So we can write cos cubed 2x as cos squared 2x times cos 2x. So you see how I split up the powers? We again have one trig function which is to the power of 1. Next, we want to express cos squared 2x in terms of sine squared x. And we can use this identity here and replace cos squared 2x with 1 minus sine squared 2x so that we have 1 minus sine squared 2x times cos 2x dx. Next step is to use the u substitution. This time we're going to let u equal to sine 2x, and when we differentiate this, du on dx is going to be 2 cos 2x, or half du is equal to cos 2x dx. So this means that we can replace sine squared 2x here with u squared, and this cos 2x dx with a half du. So we can now rewrite our integral as a half times the integral of 1 minus u squared du, and then we just need to integrate this to get a half times u minus u cubed divided by 3 plus c. And when we expand out the half, we get half u minus 1 over 6 u cubed plus c. Then we just need to replace the u with sine 2x, so that our final answer is the integral of cos cubed 2x dx is equal to half sine 2x minus 1/6 sine cubed 2x plus c. Thanks everyone for watching the video. I hope you guys found this helpful. If you're interested in videos on this topic or other topics, please do check out our channel. And if you haven't already, don't forget to subscribe. We release videos across various maths topics weekly, and we would love to see you all in the next one. Thank you and bye for now.